He sounds like something packed into an icosahedral head, to tell you the honest to God truth. And they often have recombinase sites on the outside of them. So these are probably really mobile elements that we don't understand, and maybe they go into the generalized transducing agent thing. There's something going on that we don't get here. But islands are moving around genes that are important also. And then this is a gamish, and I call these professional mobile elements. So these are things that are actually doing the job. Okay? A lot of what's also going on are these little bits like the PSBA gene or the collar toxin, things that are moving between genomes almost as single genes, okay? Whether they're moving via phage, they're actually just stuck in there. And these are called morons in the case of phages, and they're called orphans in the case of the microbes. And these are moving not through, these guys do things through homologous recombination probably, and some site-specific recombination. Actually, it should have site-specific up there. These guys tend to move through illegitimate recombination, that's when you actually get just breaks, and then you get a little bit of homology, just enough for a polymerase to extend it, right? And that's what we call illegitimate recombination. And that's why you can see these things just literally just jam perfectly into a genome.
So far as the accidental outcome, like evolution must turn that from accidental into non-accidental very quickly if your logic from over there before is true.
Oh yeah, you can definitely go back and forth between these things, and you see a lot of morons in, of course, the professional elements, right? But then these elements, for some reason, we're finding them all the time just stuck into like a microbial genome just by itself. And the moron is really, that was actually, you know how it is, the phage field figures it out about 5 to 10 years before the microbial does, right? So there's one of the best studies is actually where they propose the name moron, and this is by the Hendricks and Lawrence and Hatfull group. And so they actually could see perfect insertion of a gene into phage genomes. Okay? Later on, the orphan stuff became more apparent as we started sequencing coli and stuff like that. And this is really Howard Ochman that figured this out for the most part. Yes?
Do you create the same thing for like the global metazoan metagenome for all the viruses and everything? Would it be the same kind of process but just happening a lot more slowly?
Well, they certainly wouldn't be, no, they wouldn't look this way, right?
Yeah,
because for one thing, you don't even have modules for all
Yeah.
neurons, right? It's a very different process. I'm sure some of the underlying things are the same, but yeah.
They'd definitely be slower, right?
Well, I don't know if they're slower, right? Yeah. We can argue about that because they have so many different control levels and stuff,
Yeah.
it looks like. So yeah, maybe they have. I mean, there's some reason that we are who we are, right? With a very low amount of evolutionary time, in quote unquote. So we must be pretty good at it in some way. All right. So, and the size of this pool right now is, this is what we estimate using all these methods, and that's what I want to take you to. So what time is it?
11.
What?
11.
God, that's horrible. Okay, so why don't we just stop right there? Okay, so the next thing we'll do is we'll go into how big this pool is, right? And then how we're trying to figure out what it is. Sound good?